So welcome to the course of the microservices using mostly the Spring Boot. So yeah, coming to me, this is Maheshwar. Maybe now, as per the list I have, I'm going to ask each and everyone to give brief introduction about yourself, just to get more context about yourself. Sorry if I spell your names wrongly. Correct me. Uh, the first name is
Yeah,
starts with A.
yeah, it's Akhlaq.
Yeah.
Yeah, hi everyone. Like this is Akhlaq, working as a, I worked on two projects like a web application and one is like a middleware application like IIB as a Java developer. Yeah,
Okay.
that's
Thanks
it.
for that.
Yeah, thank you.
Hi, Dinesh. It's your turn now.
I'm working as a Java developer on the platform using Slack. I need to upgrade myself.
Okay, thanks, Dinesh. Thanks, Dinesh. But I could see some disturbance from your side, but please correct in case if you are having some questions while having the demo. So it will be easy for us to complete.
Okay.
Yeah, it's hi, Narendra. It's your turn now.
Okay, I'm working as a Java developer since last 3.5 years. Okay, and I'm working recently. I'm working in one of the extension of Java, which Liferay, which uses the Java mostly.
Okay, thanks for that. Hi, Praveen. Can you go ahead?
Yeah, hello. Hello. Hello.
Yeah, Praveen. I can hear you.
And my myself Praveen, and I work as a Java developer in Ideable Software Private Limited, and from last 3 years onward. So my role is writing the different web services for different different applications like web applications, Android and iOS, whatever. That is my role.
Okay, thanks, Praveen. And is it Selva Rasu? Can you go ahead? Yeah, can you please introduce about yourself?
Yeah, currently I'm working like Spring Hibernate web service and including like cloud computing microservice I'm working. CSS
Okay,
in
Selva.
Java.
Okay, Selva. Thanks for that. Shravan, can you go ahead?
Hi Oma, good morning. Uh, I've been working with web services for the past 6 months or so. Before that, I worked on Spring. I would like to improve my skills on the latest technologies, especially in Spring Boot and microservices. And thank you for the session.
Yeah, thanks, Shravan, for the introduction. Sriguna, can you go ahead?
This is Sheena, having 4+ years of experience with Java development, and I'm currently working with Spring Boot microservices. And I just want to explore microservices and also its best practices. I'm here.
Yeah, thanks for that, Sriguna. Is it Sunil? Can you go ahead?
Sunila.
Yeah, sorry, Sunil. Sorry for that.
Hi all, good morning. Okay, myself I was working as a Java developer from past 5 years, so I just want to update myself with latest technology. So I'm just attending this session. So I just have one doubt here: is it like microservices with Spring Boot? So I should have all the knowledge of Spring Boot, or is it fine to join this session?
No. I'm going to teach you on that. So I'll give you the content. I'm going to like shortly. I'm going to tell you that.
Thank you.
Sure. Veera, can you go ahead?
Hi all, I am Veera. I'm working as a Java developer. I have 3.4 years of experience.
Okay. I think we are done with everyone. Yep. Yeah, thank you all once again for a brief introduction about yourself. So if anyone feels it's boring time, sorry for that, but I need this context so that I can get to know like what are your background, so I can curate my course as per your needs. Okay, without any delay, let me go and share the screens. So you guys can able to see my screen, right?
Yes.
Yeah, thanks.
Yes.
So as part of this course, like what I'm going to cover is like the microservices, what all about microservices, what is like what exactly it is, how it is different from the current development methodology we have been following from past 5-10 years. That is monolithic versus microservices. There are few people works on SOA model as in service-oriented architecture. So whatever it is, like I'll be covering that. Sorry guys, if you are not speaking, can you please go on to mute? And if you have any doubts, you can come back. Yeah, thanks for that. And so what are the different development strategies or principles, methodologies we have to follow when we are working in a microservice environment? So these 3 points, like I'll be covering, so they're just a high level points, but I'll be spending in depth the time, like, okay, what are the things we need to take care if it is microservice development? It's mostly difference between this, and it's mostly an interactive session, like it's not like I'm teaching something and you have to listen. It's even I may learn during this every course of time. So let it be more interactive. Whenever you get, if you're not getting something, please pass me or else post me in the chat, so then I can reply back to your comments. And so mostly this course is microservices is not just to give a very high level. It's not attached to any technology, so it can be done in .NET or any way. I'll come to that point even in more details in the coming slides. But as you know, like mostly this session or this demo, not demo, this course will be more concentrated on Java, that is Java related technologies, using microservice development using Java. So for that, the obvious feature like is a Spring Boot. So so I'll go what it is Spring Boot, and I'll be giving a demo on developing a small Spring Boot app. So there is something called initializer, and by using that you can quickly bootstrap a small Spring Boot app. So I'll be explaining you that as well. And there are some beautiful points called Spring Boot actuator endpoints. What are those actuator endpoints? What is the benefit of using them? So how to enable them? All these things I'll be discussing as part of Spring Boot. Even I'll be discussing more and more things. I haven't put it in the notes. But it's like on dynamic, like whenever we are explaining something, if I see even if I need to explain more on, about a particular concept, I'll be explaining more on that. And mostly the build tools will be, I'll be using Maven or Gradle, but I'll be covering both. Mostly we'll be using Maven, but it will not. So maybe I'll be giving a demo based on Gradle as well. But I'll be explaining you how to use Maven and Gradle. In case if someone used Maven, it will be easy, but otherwise it needs some knowledge on using Maven. And so source controls, so for code version management, this is like in our daily project as well. Whenever we are committing something, we need to know, okay, we need to have some version source control tools. So I'll be using Git mostly, but it's not that if you want, you can have any source control in your project. You can have SVN, you can have CSVR, there are something called workflows. So anything you can use, but Git and GitHub. So I'll be using GitHub for pushing the data. Even I'll be asking you guys to setting up the Git and GitHub in your machines, so that even we can, if I'm giving small POC kind of thing, if I'm asking something, you can push it to a repository and I can review it. So it's like it will be like what we are doing in our daily in our office. So GitHub is, most of you guys know, it's like a public repository. Even it has a private stuff, but private is for mostly organization. Public is something like to us to push some our code or our experiments in a source code, in a cloud basically. And then coming to that, after Spring Boot, so Spring Boot, this covers only the basic points. Now we have to go in detail, like developing a REST API. Mostly I'll be concentrating on REST, how to develop a REST API using Spring MVC, or if someone want to have something else, we can discuss, but mostly it's a Spring MVC way. So I will be developing a small REST endpoint. And then after, so once you have a REST endpoint, now we want to store our data. So that's where something called Spring Data is there. So Spring Data is like a data store agnostic. You can work with MySQL, you can work with Mongo, you can work with Elastic, you can work with any storage. So I'll be giving demos based on GPA and Mongo. Mostly these are two things people uses. If someone want to, someone interested, we can also have some sample code to connect to multiple databases using the same from the same project. So these kind of things I'll be discussing more on that. And there is something called profiles. why we use the profiles, what is the importance of profiles. So all these things I'll be discussing as part of Spring Profile module. And to communicate from one service to another service via REST, so we have something called REST template. So I'll be giving an example to how to use REST template. As part of it, we may have something called retry template. So these are all the different components I'll be explaining to you. And so the next interesting stuff is Spring Cloud. So what is, as part of that, I'll be covering few modules in general most of the companies uses. So the Spring Cloud config, what exactly it is, what is the benefit of that, and then Spring Cloud Slate. So Slate is like because with the microservice world, you will be having too many services. You want to know, okay, the common trace ID, then Spring Cloud Slate will be the best tool to use. I'll be explaining more in detail when we are coming to that particular part of that. And then so I'll be also touching messaging framework like using Kafka. Mostly no one, very few companies uses this. I would like to give this as well to the content. And there is something called Spring Cloud Bus. It is to push the configuration automatically without restarting the services. So these are all new stuff. And then after, there is something called service discovery and service registration. So we have Eureka from Netflix. I'll be explaining it. What about Eureka? Why we need this? Why we need it in Microservice world? And there is something called Ribbon, client-side load balancing. What do you mean by client-side load balancing? What is the importance of load balancing at the client side? All these things we'll be discussing. Then after so I'll be explaining you about Docker. What is Docker? Why we need Docker in Microservice world? What is its importance? What do you mean by containerization? How to so these are all things I'll be explaining. Then when I'm explaining that, most of the people will be getting doubts. Okay, how it is different from virtual machines? So how Docker is so fast than compared to VM? So all these things I'll be explaining in detail. Then after that, we'll be working together to create a Spring Boot app Dockerized into basically containerized using a Docker image. So it's like wrapping your Spring Boot stuff into a Docker and restarting it. So these kind of things I'll be discussing more when we are going into the Docker things, because in microservice mostly we'll use Docker to package your software and to ship it to cloud. And so there is something called CI/CD, like most of you guys might know. So I'll be touching Jenkins. What is the importance tool? What do you mean by continuous integration and continuous development or delivery, whatever you call? So I'll be discussing about that as well. And then I'll come to AWS. So what is exactly AWS? Why we need it can be AWS or Google Cloud or Amazon Azure, anything. But I would like to take AWS because most of the companies prefer to use AWS. But it's not mandatory. You should have AWS for microservices. You can have your own data center as well. But just for a knowledge gaining, I would like to add this. So I'm adding as part of this training. So in that, what is AWS? How to create machines in AWS? That is called EC2. How to create a software, or like how to take a service, a PaaS model. AWS is kind of a PaaS model, platform as service. Means they will be giving some softwares installed already. Like for example, if we want to use the MySQL database, so what we do, we go to a Linux machine, we install MySQL, and but instead of that, we can ask Amazon, can you provide us some MySQL database? They'll create everything. They'll take care of everything. They just give us the host name. We can directly use. We don't need to bother about the setting of the MySQL. So this is called our shared services or platform as service. So I'll be touching mostly using RDS, so relational database service provided by the AWS. Maybe while discussing, if someone has more and more things, I can cover more. Like we can discuss about Elastic Load Balancer, all these things. So this is all about the course content. It's not restricted. If something interesting, while we are going to the session, you can open to ask me the question. You can post me on the chat. If I'm already known, I can explain you. Otherwise, maybe I'll get the things and come back to explain to you. It's not like I should know everything, because I'm and I would like to explain you guys. I'm using microservice methodology from past 3.5 years, because it just started and like 3.5 years is mostly I'm into it. I'm almost in these 3 years I've developed around 30 microservices individually. 30 services I've created myself to the company. Okay, so this is all about course content. I'm going to put a pass on here. If anyone have doubts on the course content, you can post in the chat or you can ask. So silent, I'm giving 1 more minute. Either you can post on the chat or you can ask me directly. If no response, I can assume that you guys are okay with the content or happy with the content, which I'm going to deliver as part of the this training module, microservices using Java. Okay, I got a chart. Okay, this is a good question. Thanks, Ravan, for reminding. The prerequisite is you should know Java first, and the second thing is if you know Spring, that would be great. At least the basic knowledge of Spring is required, because I'll be showing a lot of examples, not the theory, actually the practical examples. I'll be relating it to our real-time work, like how we use it in our workplace. So it's mostly example-driven training than the concept-driven training. So the good to have is Spring, only the Spring core. If someone didn't work on Spring yet, so maybe you can refresh on Spring core concepts like dependency injection. That's it. Not much, not more than that. Rest of the things I'll take care of. Even if you don't know dependency injection, I'll try to explain you. Maybe with the example itself, but I will not spend more time on what is dependency injection, what is construction injection, parameter, those kind of things I'll not be taking care more. But I maybe tell you, okay, what is the best way of using a dependency injection based on the examples. Anyone have question? Thanks, Ravan, for asking that good thing. And yeah, coming to the developer setup. So like, what are the things we need for this? So I need it would be so on your laptops you need to install basic Java 6 minimum. If you have Java 8, that would be great. And any good IDE, Spring Toolshoot or IntelliJ. That I prefer IntelliJ, but any IDE. Yeah, Maven or Gradle. If you don't have Maven, please install Maven. That's it. Mostly I'll be using Maven. Maybe one example I'll take Gradle, but Gradle I not much. Like mostly I'm using Maven only, because most of the people uses Maven, so I want to put that only, because there is no much difference between Gradle and Maven when you're using, but internally there is a difference. But for microservices relating, you should not pay attention to that. Anyone have any more questions? Okay, so I assume that so everyone is fine with this, because I didn't see any charts or any questions. Yeah, thanks for that. So okay. So I want to repeat it again and again. So it's mostly example driven, the code driven training, mostly code and code. The concepts relate to our application development, not on the theory. As part of this, like I'll be giving slides, and most of the code will be pushed to the GitHub. So you can see even after the training completed. Like for example, if I'm explaining a topic called Spring Profile. Okay, I'll explain you what is Spring Profile, but you need to have a code to see it, to review. So I'll be, whatever the examples I use, I'll be pushing it to a GitHub repository. You can clone it. You can read it from anywhere, like whether you're in office or whether you're at home. Like you just download it and you can see it. So that's how it works. Yeah, let's go to the topic directly. So this is all about the content, and now let's. So before going to this, what do you have, like what are you guys are thinking, like what do you mean by microservices? Just any experience, like few people already started using it. What do you mean by microservices?
Microservices means it is a continuous deployment process, and we can achieve module level of implementation.
Okay, not completely, but a subset of it item your understanding is correct, but not completely that. Okay, thanks, Shravan. Is it Shravan or like? Yeah, thanks for that. So it's someone Shravan replied saying the small loosely coupled RESTful services. Yeah, okay, some extent. Okay, so you guys have few basic contexts. See, the word itself saying micro is something small. Okay, it's a small autonomous services loosely coupled, means they are not tightly coupled to the system. Loosely coupled, mostly communication using a open protocols like mostly HTTP or REST, but it's not restricted. You can use any protocol. So there's a small service with a small business context, a well-defined business context, and communicate with if you want to know something, you always communicate using a REST web service. It's like a loosely coupled system, a small web service, you can say. The definition itself says a small autonomous service that works together. Okay, I'll go in more and more details about what is microservices. Before going to that, actually, why we need this? What is wrong with the current way of methodology, current way of development? So to know that, let's go and revisit what we are doing today. Like before microservices, what exactly, how the most of the people, what kind of architecture or what kind of methodologies we have been following for delivering our software components. So that is called monolithic. So in monolithic way, like, okay, what you will be having, you'll have some presentation logic. That is something like, okay, set of HTML or Angular pages, whatever you call, or JSON. So there is one presentation layer, mostly focused on UI logic, and a business logic is a very thick stuff, like a lot of modules and packaged as a var or whatever you call. So there is a business layer, and there is a database access related code to connect to databases, either MySQL or NoSQL databases. And there is some integration pieces, like if you want to send a message, if you want to send an email, if you want to call someone else, some other services. So these are mostly like, these are the key components a monolithic application will have. Are you guys agreed, or like, is it clear so far? So generally we'll have a presentation, a business logic, a database access, and app. Okay, let me take an example how it will be. So if you take a car hailing app, a car pooling related concept, okay, like what kind of things? For example, take a Uber or Ola, whatever it is. So what kind of application architecture they will have without microservice? Mostly like, you'll have some module to manage the passengers. You'll have some module to manage the billing. You'll have some module to manage the notification when sending SMS, emails, everything. You have some module to manage payments. You have some module to manage the drivers. You have some module to manage the trips, like bookings. Okay, so these are all things will be packaged as a into on one single application and deployed to either Tomcat or JBoss or whatever some application containers. And you will be having some UIs, maybe a mobile UI for a passenger, a different UI for driver, and there will be a REST API. You will be calling your backend services, so that will fetch you the passenger related information or driver related information. And you will have some desktop UI for admins, or even now. Earlier we used to have web apps for people as the passengers or the end users, but mostly now end users are mobile driven, and web UI maybe for a backend admin guys to see if something goes wrong. And so this backend layer will be communicating to your SQL database or your persistent storage using some MySQL adapters. So there will be a DAO layer, or maybe a DAO layer here only, but like your customized drivers, MySQL driver, a JDBC driver, whatever it is. So there will be some adapter to communicate with MySQL. And you want to send messages. So there is something called Twilio. It can be any adapter. So it's a messaging adapter. If you want to send an email, you want to have an email adapter. These are SendGrid and Twilio is just an example for that. These are the companies who provide these services. And there is something called Stripe adapter for payment stuff, payment related. Like you can assume it as a PayPal or Paytm, whatever it is. There are some third parties for managing communication or a payment related. So there will be an integration kind of. So mostly our architecture will be like your most of the key logic of the business will be lying here. Okay, and what we'll do, we'll package as a var. okay, and we deploy into Tomcat web app folder, or some, if it is the WebLogic, it will be in a different location, and then we restart, and then application will be coming up, and everyone will be start using it. Okay, so this is how a typical, and it may not be exactly exact architecture of you guys are using at your workplace, but somewhat related. Do you guys agree?
Yes.
Yes, yes.
Yeah, thanks for that. So now, okay, what are the this is the way we are working. Okay, now what is the benefit of, first let's go with the benefits and then go with the problems. Okay, so this model, okay, your most of the code is at one place, so simple to develop. You can just go to one, if you want to have a small change, just play, if you want to have small enhancement, go to your code base. Just what we do, we set up the code base into our Eclipse or IntelliJ, and then we should know, okay, what is the corresponding place we have to change. Okay, we'll do the changes, we'll test it, and we'll ship it. Simple to develop, simple to test, because entire application is one place. Just once you deploy your stuff, so there will be some automation script or manual testing. You just launch your app. You don't need to worry about it. So I have deployed the latest version. I test it. Simple to deploy. Why? Because you're having only one package, one jar, that is one var with a complete software, complete components. Even though you have a multiple layered components, like you layered it, like you have a passenger, you have payment, but all are like, it's maybe it's something like a different modules. They are not different services. They are like, mostly few people also use the services. That's where the SOA comes into picture. But just mostly it's like a libraries you'll have. So you package into a single var and you deploy it. So deployment is so easy. Just package it and deploy it. Deployment, there is a different team. Generally, few companies manage a separate team for deployment stuff. So for them, it's so easy. They just take your var and they deploy it onto the corresponding environment, whether it is prod or pre-prod or dev or whatever the environment it is. And scaling, for example, what do you mean by scaling? I have a software running. Maybe most of you know, guys have some context of scaling, but I want to give very brief idea about it. What do you mean by scaling? So this is a carpooling app. Everything is packaged to a single var and deployed into Tomcat. We are running one instance of it. So suddenly our idea got clicked, and many people are started using our application. So what happens? The load on the application will increase, right? So then what we have to do, we have to scale the application. Means we have to deploy the same application one more time. Means we have to spin multiple instances of same application. Means the entire application we can scale just by deploying one more instance and backed by a load balancer. What do you mean by? Just I'll give you a pictorial representation. So this is, just assume that this is one of our So if you assume this is our app and this is backed by a load balancer, and like end user are hitting our web service or our application. So okay, for few requests it is scaling, but now let's suppose that if there are many people are using, then what we do, we deploy one more instance of our entire application. Means we scale it. This is called horizontal. It's like X scaling. You're just spinning up the entire application to one more time. So now load balancer will get to know, okay, there are two pieces of this context. So load balancer will send some traffic to one server and another traffic to a different. It's like a clustered environment. Most of you guys might know it, but this is how it works. Okay, so scaling is so bit easy. Why? Because you just need to spin the entire stuff one more time. If you want more, you just add one more. So scaling is easy for the infrastructure guy, whoever manages the environment. In case if they're seeing a lot of traffic. But okay, I'll come to there is a problem here. I'll come to that point when I'm discussing the problems with my monolithic. So so scaling is easy, simple to scale. Okay, now there are a few things. Even testing is simple to code, simple to deploy, simple to scale. Okay, you're saying a lot of benefits, but why people are going to microservices? Okay, so that's where the drawbacks. What happens, for example, you started a project today, a fresh project we started, we have added something. Okay, everything is working fine, we packaged as a var or whatever, EA or var, anything you're shipping and everything is going well. So idea clicked. Now what says product people come, product or business analyst comes, okay, we want to add few more features. We want to add few more features. Okay, what we do, they'll come to come to development team, they'll give their enhancements. So we keep on adding the changes. We keep on adding more and more code. So it started today. After 2 years, the project will be so huge. Thousands of code, lines of code, lot of module library dependencies. If you're using Palm, your Palm will be so big, it's hard to understand. And it's like, for example, after you started today, and after 2 years, you have been adding too much code, and you become a subject matter expert in that. And after 2 years, you're leaving the company because of your career aspiration. Now see the risk. You have the most of the knowledge, okay, and if you're leaving suddenly, and they'll stop you, they'll say you have to wait for 3 months, because a new joinee should know about all these things. Otherwise, a new person joins, you should know the complete code, or at least some context, not complete. It's highly possible, because if you want to know in and out, you have to spend more and more time. But to have some basic idea, because the whole logic is placed at one place, even though it is modularized, but there will be a lot of dependencies because they are strongly tied or coupled internally with like for example, you have an account service, you have an order service. If someone is calling order, if you want to know the particular user details, you will call account a method. So internally, it's like a method call, but it's a tightly coupled system. So it's hard to maintain. If your project is growing like anything, then it will be like a monstrous monolithic application. Even if you want to set up the project in your IDE banks like anything, it just shakes because there are a lot of modules to set up, and it takes 1 to 2 hours to set up the code itself. Not forget about the complete setup. Just to import the code, it's 1 to 2 hours. Few people might have experienced it already. And if the code is big, you're packaging everything into a single file, a single var. So even the deployment, when you are restarting the service, it takes more time. Okay, it takes, like, for example, I'm doing some change, I want to test, I started, it takes 10 minutes. What I mostly, like, few people might have experienced it, whenever you're enhancing some changes, when you're adding some changes, you add the changes to test it, you start the service, you start the complete Tomcat, or what, you'll start your service with your code, you'll go for a tea and then come back, because it generally takes 10 to 20 minutes, sometimes even hours as well, if you want to start an entire project. Depends on the size of your project. So there is a time delay. So the deployment also takes, whether it is local deployment or whether it is a deployment in a server as well. Okay, and for example, as what we are doing, we are packaging complete thing into one piece. For example, I got a requirement in one module, say account. I'm making changes there. Now, if I want to make a changes, what we do, we change it and we deploy it to a separate version, and we package into a separate version, and then we deploy it to the server. Now it's like deploying the whole thing again, right? Now testing team says no, we have to test everything. Our regression needs to be happen, because even though it's a change in account area, they never trust us. They say that okay, we want to test everything. It might break something else as well, because you are just replacing entire software. Even though you can say that it's a small change in one module called account, but they have to, they cannot certify the deployment. So what they do, they will test entire stuff again. So means testing phase, each and every change, if you want to push to prod, it takes a lot of time. You have to test locally, you have to deploy it, there should be a testing phase comes, they have to test, and then they have to deploy. And the complete deployment, okay, forget about the local deployment. You might have heard like in your company, okay, this weekend deployment is going on. Why the weekends? Because the complete deployment of your project, if you want to deploy, it takes minimum off day to a full day. Like if you even take a database scripts, everything, like If you're, for example, everything is working today. Now we got to know that we need to add one column in your one column into a table. So now what changes we'll do? First, you need to write an alter script to your database, and then you need to change your models, that is entity classes, and also model classes means the responses. So you added all these things. Now you want to ship it. What you do? You package it, you deploy it, test it. Testing will be like the testing only on that area, and also a regression testing means to check very high level all the parts, and then you ship it. So it takes 1 to 2 days to ship a small change to production. So there's a lot of effort. And so what do you mean by 1 to 2 days? Why can't we do a continuous deployment? I want to change, I want to deploy immediately. That is not possible. So means continuous deployment is the pain in monolithic. Okay. I'm sorry. So continuous deployment is a bit difficult in monolithic way, because the way we architected, we are managing the source code, it's highly impossible to deliver immediately. In microservice world, it's easy. Like if you trust or not, daily we send patches to production with highest quality. You will guys get to know how it is possible, but I'm telling you that. And the starting the web container is taking time, but if you use Docker kind of things, some containerization stuff, to come up to boot this service, it takes just 2 minutes. With the latest code, if you want to restart the service with a redeployment of new code using Docker, it just takes 2 minutes to boot the service. And impact of changes is not very well understood. I've been discussing, for example, I changed something in account, but it's not easy to understand. Okay, it won't impact the other modules. It might impact, it may not impact. Only senior people will be in a strong position to tell with the experience they have, okay, if you are making this, it will not touch, it will not be having much impact. But that's more into our own self-confidence, but not on the code wise. So, and reliability, yeah, these are all things I discussed. And the the big problem with monolithic is, see, from 2 years you have been using one technology and it's working well, but it is not up to the mark. Now we want to take a decision. I want to go with a different technology. Now, if you want to take that call, it's very hard. It's very hard to convince the company. Means you can't use a new technology easily, because you have been writing the code with the old way from past 2 years. If you want to rewrite it again, if company asks us to, the management asks us to give the estimates, we say minimum 1.5 years. And no one will be ready to spend 1.5 year time to change the technology. They will, okay, let it carry on. That's fine, no problem. We don't want to invest money of 1.5 year like 1.5 year time with human resources. But say no, don't go. That's a problem with the big clients like banking clients or telecom clients. Their code is so much huge and mostly tied to particular technology. If they want to change technology, it's hard to take the call. If they're taking the call, it's a big project, lot of openings outside. If they say, okay, we are changing from, even now it's happening, many companies are migrating from the SOA or monolithic way to microservices. What they are doing, they have to take some hard call. So they're doing it now, and they're recruiting many people, because it takes effort to convert into microservices. That's happening. So that's all about the drawbacks of monolithic architecture. Before going to what exactly about microservices, I want to give a pass. Like, anyone having questions on so far I've been discussing?
Hello.
Yes, Suresh, tell me.
Yeah, we understanding what you said previously. I mean, it is monolithic architecture. There are different, different types of disadvantages are there, right?
Yes.
Yeah. By using these microservices, we rectify that this type of disadvantages, right?
Yeah, so like what, okay, just to add, like when I'm explaining microservice in detail, not today, it takes time to, I'll explain you a concept, how it is solving, what was the problem with monolithic, and how this concept in microservices is solving the problem. For example, scalability, how effectively we can scale in microservice.
Okay.
These kind of things I'll be explaining you. I haven't touched the microservice yet. I've just, so far I discussed what is monolithic way of development, what are the problems with the current. First, before learning something new, we should know what is the problem in the current model, right? So I've been discussing on the current model only so far.
Yeah, fine.
Anything else?
Nothing.
Yeah, thanks for that. Okay, so I will be taking 5 more minutes. Like in 5 to 10 minutes, will be ending with this demo. Just to now, I'll touch what is microservices. Maybe very few benefits of it, and because to go into details, it takes more and more time. Like it takes minimum 2-3 hours to explain more details about microservice. Now, in the next 1-2 slides, I'll be touching the microservice, and then when we start the class, actually, I'll be spending a very detailed discussion with all of you guys and to understand more about microservices. After discussing about microservice only, we'll be entering into Spring Boot. Okay, first 2 days it will be mostly like a conceptual training. Okay. So what is microservices? Okay, so far what with the monolithic way we are placing everything into one place. Okay, now what microservices, don't place everything in one place, just split it into small pieces. When you're splitting, you define your business context. All related business, keep it one service. For example, all account related one service, all order related another service. Earlier what we used to use, account order maybe separate module, but they will be connecting to the same database. Here they said no, don't do anything. Your account should be having its own database. Order should be having its own database. If account wants to connect to order, just communicate via REST. So it means there is the perfect boundary of your context. What are you doing? Just do that only. Don't put a lot of things. Okay. So what they say is like you split your application into small pieces. They are interconnected via open protocol, mostly using REST, or it can be anything where some other people can understand. And so internally you can have your own architecture if you want. You can directly connect to your database. You can directly send a message to some other service. It can be any hexagonal or layered inside, it's okay, but you have to define a boundary what you are doing. You should not put lot of things in one place. So that is a very high level definition of microservices. So usually coupled autonomous services with strict business boundary context, and always connects with other parties via REST or open protocol. Okay, that's they call REST or RPC or messaging framework, anything. You can have few services even without REST. It can be a microservice just for UI. You can have your Angular app. You can have some other technology. And one more thing, microservices means it's just a development methodology or practice or an architecture. It doesn't have any strong relation to Java or anything. You can follow this methodology in any technology. For example, I can say I can have my one microservice in .NET, another microservice in Java. You can communicate via REST. There is nothing wrong. So means there is no technology bounding with your architecture. You can choose your own technology. So the problem with monolithic is your most of the code is written in one language. If you want to change the technology, it's very difficult. But with microservices, you are creating a small portion of your application in one service, and so that your code is very small. Generally, people say that microservice one team, maybe like your team size should be around 5 to 6 people, or even less than 6 people, or some like few companies 2 people per service, something like that they have. So 2 pizzas should be sold to the whole team. So your size of the team for a particular microservice should be, if you compare, like it should be very small. So that what's the benefit with that? See, you have written a microservice, means you're defining your context. It is so small. For example, you're leaving the company today. If someone else joining, they can open the service. They can hardly around, maybe if you take 30-40 classes, just 2-3 days, you can scan the classes. You can see what's happening. You know for example, if you're talking to someone else, you can see the interaction via, okay, there is a contract. There will be something called client libraries. If I'm talking to order management, I don't know. For example, I'm joining a developer into account service. So what I will be doing, I'll be just cloning the account related service code. Okay, I'll be seeing the classes, I'll be seeing the dependencies. Okay, now I'll be seeing some code where whether I'm talking to some third parties like another service or another. That's just a contract. You can see the contract definition. You can easily understand. So onboarding a developer is so quick with this model because the piece is very isolated and loosely coupled. And so if you take the same example what we have been discussing with the microservice model, the carpooling app, so that this will be something like this. So earlier it was like this. If you split into microservice way, it will be like this. So there is something called API gateway. So you have a passenger management service. There is a service for it deployed as a separate process. There is a billing service. There is a payment service. There is a driver management service, trip management service, notification service. There is a UI service for driver's purpose. There is a UI service for passenger purpose. So there is a gateway service like to accept the external traffic. Like for example, if a user is calling a passenger, like I'm a passenger, first it will go to passenger management service. Now it will call, for example, if I have something related to payments, it will call payment service. If I want to book something, if I'm sending some messages, something related, a notification service. For example, if there's a driver also will be having connecting to payment service. They'll also send notification. It's all like a service to service communication. Like if I want to talk to someone, just make a REST call. Okay. So all this is how it will be. But there are some problems with microservices as well. I'll come to that. It's not that microservice is so great because so what happens is slowly you keep on adding services. I'll come to that now, but this is how it will be on the microservices. So the benefits is, so the complex problem is decomposed into small application. So you can choose any technology. So means there is no technology heterogeneity. Means you cannot you are not tightly coupled to a particular technology. Basically, microservice methodology is technology agnostic, ease of deployment. For example, like I was saying, there is a change in payment module. I just need to deploy this part only, not the complete part. Only changes here. I'll be making the changes in this service. I'll be deploying that part only. So you don't need to test entire process. You just need to test this process. And the resilience. So there is something, for example, earlier, if there is a failure in your code, your packaged as one particular component and you're deployed into one single service. If there is an issue in any piece, complete system is down. If there is some problem with the trip management, your complete app is down. That is too hard to digest. Only small issue with the trip, you're saying my complete application is down. But if you split into microservices, only let's suppose that payments are not working, but still you can accept the bookings. Payment service is down, you can accept the bookings. Means your app is up, but only it's not working fully. It's not working fully. There is a partial problem, but you're okay with that. You're at least getting bookings. Once you're fixing the payment problem, you can do the payments. The payments you can accept later stage. So there is a lot of flexibility with this model. Scaling, I'll discuss more on this. What is the scaling meant? For example, if you want to scale this app earlier, you have to spin the entire app. You have to spin the entire app one more time. But the scaling may not. So the problem with that approach is, for example, I'm only using a particular part of component a lot. But maybe people are logging a lot. They're not going to payment related things. When you start your application, a lot of people log in. So there is a lot of loaded accounts. I don't want to scale all the complete app. I want to scale only account app. So that is possible with when you're splitting your service as an account service. Just spin only that particular part, not entire part. You can spin 5 times of your account service. So you have 5 instances of accounts, remaining are one. So your resources are optimally utilized with this model. So I'll come to that even more detail, but just very high level. So scaling is so flexible here, so easy here. If you want to scale entire app, it takes 1 hour, maybe 20 minutes to start the entire application. But if you want to start only one particular service, if you want to scale only one particular service, it will be so quick because your code is minimal. Means your size of the jar is also very small. It can come up in 2 minutes instead of 20 minutes. So these are the benefits, but there are problems. The problem is now the code is deployed into multiple services. Managing the, and see, you can see there are a lot of communication happening via REST. Means you are making an internet call. Earlier it was like a method call. It might have been fast, but now you are making an internet call, a REST call. So it might be, there will be some latency problems, but there are ways to cover that. And one more problem is you have to manage all these services. Means you need to have some separate infrastructure that is called Eureka or Ribbon, what I was explaining, to manage these services. So that's called service management. So the problems you take, managing too many services. And earlier mostly we'll be having single database. Now we'll be having a database per service or a schema per service, maybe a single database, but you will not share. It's like passenger related tables cannot be accessed to billing service. So if billing wants to need some information, it should contact passenger via REST only, not directly tables. So I mean, there is some database transaction things you need to split. So there will be a problem with the consistency, but you need to architect your application in such a way that you can have eventual consistency. I'll explain you more on this when we are going to that particular stuff in the microservice. What do you mean by transactional problems? But overall, you are removing earlier you have all your tables at one place. You can make a joins and you can make a transactional log. You can make a foreign key, all these things with the different tables. But with the microservice world, you're removing it. Means you might not have some transactional things, but it's not hard to get it. So the one more problem is deploying microservices is complex. Testing microservice-based application can be a bit cumbersome because now you cannot do end-to-end testing. But for doing end-to-end testing, there are different methodologies. Sorry for that. I'm a bit cold. So now coming to deployment, so you have too many services to deploy. So there is some additional effort will take care. We have to take to deploy these services automatically. There is something called Kubernetes. Maybe I'll be even though I didn't mention that in the course content, but I'll be explaining you what is Kubernetes, what is the benefit of it for deployment of services. For a developer, it's not much needed, but having the knowledge is not bad. And one more thing is, in the microservice world way, your team will take care of everything. You have to code, you have to deploy, you have to test. Means not a developer, but your team, your Scrum team or whatever the team, whoever was that service, entire thing, even the deployment, the service in the prod as well. Earlier there will be a separate team to manage all your services. Now it's your responsibility to take care of your service from end to end. So this is all about microservices. Maybe I've touched very high level points as it's a demo. But in the course, I'll be going to each and every topic with a detailed discussion with the slides and with the code bases. So first few days more onto concepts, and then after we'll be using Spring Boot to develop application, to develop an endpoint, to store in the database, to spin it, and to create a Docker image and all these things. Yeah, that's all about the demo. I'm going to mute. If you guys have any questions before closing, I'm open to answer.
Hello. So
Yeah,
what about performance?
Yeah, that performance issues will be there. I was explaining you, right? When you're making too many calls, there will be performance problems. How we handle using microservice, there are tools. So example, client-side load balancing to reduce the network calls. But that performance is not too much. Just to understand the benefit we are getting, if you take a relatively, earlier it was like method to method call. Like now it's you are making calls for REST. The benefit we are getting because of the splitting might be comparable with the performance, but it will not impact the performance a lot. There will be, if you compare like side by side, a little bit time it takes, but to even to reduce that time, we have good tools, good frameworks available. You have to take care of that. And then we have to use. It's not like okay, everyone cannot use microservice. You have to decide as well what kind of project you have, what is the complexity you have. It's not like a okay, if my project is running today on something, okay, I need to migrate. No, it's not like the call. Well, how big is your application? What is the importance of you? What is your business need? For example, with microservice way, if I want to give a small, for example, if business is coming with some concept, they want to evaluate whether it is possible or not. What we do, we can quickly bootstrap a one microservice with that concept. We can show them immediately because your context is separated. Yes, you can innovate more. Whether if it is a case of old model, you should know the complete picture, and then you need to put your code at particular places with proper like maintaining the conditions. Okay, this is for demo only. Don't run only for demo. All these kind of things. It is a bit hard to do proof of concepts in, like, even if you take to prove evaluate or whatever you call in a old way of methodology. But with microservices, it's easy. And with one more thing is you can also run two versions of same service in microservice methodology. For example, I'm developing something new. Okay, let's take an example of a payment service. We created something new in the payment, but there was an existing service as well. Now I want to run two versions of it, maybe one version for particular customers just for testing purpose in production, not in local. I want to test with a real user. With microservice, it's possible. So there are a lot of benefits. Okay, what is the importance of Puppet in the micro? Maybe it's not like Puppet is like a DevOps tool to script to automate the deployment process, but it's not at all required.
Thanks, Mama. Actually, we have Jenkins TeamCity, right?
Okay.
How different between these two, Puppet and
Okay, so
Jenkins?
I'll explain you that. For example, you created. See, we go with the basically here. Puppets. Few companies do create. There are some voice coming.
Sorry, your voice is a bit breaking.
Yeah. So Veera, like how it works is everything, whatever we need to package our software into Docker, we mention in the POM only, pom.xml.
Yeah.
Okay, if you know Maven. So with a few commands, you can build your software. Let's say Maven package Docker or Maven clean insta. So these things, what they do, they're using those puppets, and they automate these steps. For example, when you're shipping it, what you need to do, you have to test your code. Because there is a phase called testing, Maven test. They create a Jenkins jobs for that. I'll explain you one bit more. Like for example, if I'm committing some code to a main branch, people call it as master in Git world. So now, as soon as I commit that code, so there is a phase involves. Okay, you committed. Let's run the JUnit. So there should be a job. You run the JUnit. So that triggers the Maven test. It runs the JUnits, then it does the packaging, and then it deploys to particular environment. Then there should be automation tests. So there should be some job to trigger that automation test after deploying. So all these things will be managed by Jenkins to trigger. It's basically jobs. You create set of jobs to ship your code. If you want to ship to different environments, you can create that using Jenkins.
Actually, I have used TeamCity and Jenkins.
Yeah, sorry, Veera. If you have more questions, we can have a one-to-one communication. I don't want to stop everyone, but maybe I have given the very high level answer to your question.
Yeah,
thanks, Veera. Anyone else before closing the session? Yeah. So last 1 minute, I'll be waiting.
Okay. Hello, Umar. Hello.
Yeah, yeah, Praveen, tell me.
The thing is, we have multiple module specific WAR files for
Okay.
one project using microservices. Hello.
Sorry.
As per your example, we have multiple modules for payment and booking, something like some
Yeah,
each
correct.
module each WAR file.
You can say it's a var, but we don't use var. We will say jar now. There won't be any var, and we don't in Spring Boot world will not be using any enterprise containers. It's mostly Tomcat open source container. So now earlier it was some jar packaged with a big var. Now what we'll do, we'll putting that particular, we'll be splitting that particular library, and we'll making a service using that. So the service will be packaged as a jar now with the Spring Boot. We call it as jar only, no more var or ER. Someone calls R enterprise R. If you are using beans, EJB beans, you call it as ER as well. But there won't be. But to give you more, yeah, you can assume it as a small vars, small vars. They are separate services. There won't be any single container now. Earlier, for example, if you have multiple, you will be deploying on one single JBoss all separate vars. Now it's not like that. You will be having your own container, a bootstrap embedded container. You'll be understanding more when I'm giving you a Spring Boot demo.
Okay, thank you.
Yeah, that's all, guys. You can still put the questions in the chat, but with this, I'm concluding the demo. Thanks for attending once again, and hope you guys you will turn out to the actual training. And in the training, as I told, like we'll be covering a lot of examples because we have very like only 10-15 people. We can openly discuss the questions. We can understand. Try to be more interactive in the session so that you learn. You are actually spending this 1 hour time in a good way, so that you got something from this training. You learn something new than what you are doing. It will be benefit for all of us actually. Thanks for that. See you on the class.
Thank you, Umo. But one question: when you are planning
Yes.
these sessions and how long it will be?
It will be a month time, an approximate 30 hours it will take, but around 30 to 35 hours. But don't count on the numbers, an approximate 30 hours. Depends on the grasping of people. Because if too many questions comes, then it may stretch. But overall 1 month time, if we continuously connect it to the classes without any disturbances.
Your preference timings to the session?
That you can check with the support team. They will tell you the complete things. But we haven't decided timing. Mostly I'm thinking in the morning times. But we have a couple of batches planning. So you can think about it, the flexibility. But the first batch I'm thinking mostly in the morning. If it is online, even not yet decided whether it is online or face-to-face. It could be online if everyone accepts. So we can connect early in the morning, and then we can finish the training and we can go to our work.